Hi, in this video we're going to look at calculating the angle between two vectors. So we're going to start by looking at vectors given in polar form or given with their magnitude and direction. So I've got two pictures here. Let's work on the left one first. If I want to determine the angle between vector A and vector B, and I haven't stated the magnitude here because I don't need it. If I want to determine this angle, you can visually see that that angle there is going to be this big angle minus the smaller angle. So we can just say theta is 110 degrees. Now on the right, we can look at it. If we want to find that angle, and when we're talking about the angle between two vectors, we're talking about the smallest angle. So over here we were looking at this angle, we weren't looking at this big one that wraps around. So we're looking at the smallest angle. So in this picture here, we can see that the smallest angle is going to be this one. So one way to calculate it in this instance is to say, well, this is 110. What is this little bit here? If I call that theta 1, you can say theta 1, 20 degrees, and then our theta, so our angle between our two vectors is just 110 plus 20, which equals 130 degrees. So there's two methods that you can use to calculate the angle. Now, it becomes a little bit more tricky if the vectors are just stated with magnitude and direction and you don't have a diagram. So I'll show you what I mean with that. So let's say we had vector A and it had a magnitude of 10 and a direction of, say, 110 degrees. So we're writing it in our polar form. And vector B, let's say it has a magnitude of 20 and let's say 330 degrees. Now in this case, it's a little bit more tricky to see, are we doing the subtraction method that we did over here? Or are we doing the addition method that we did in the right-hand diagram? So if you're not sure what to do, you can do either, it doesn't matter. So if I was to calculate my theta in this case, let's do the subtraction method. We do 330 minus 110, gives us 220 degrees. Whenever the angle between two vectors is bigger than 180, it means it's the larger of the two angles. So showing that over here, if we have 110 degrees is somewhere there, 330 is somewhere there, we've found this angle here. So it's going to be a smaller angle on the other side. You can always find the smaller angle by doing 360 minus 220, which gives 140 degrees, which is this side here. Now you could do the addition method that we did up here, but that's probably easier if you draw the picture, seeing visually that that is 110, and then seeing that you can calculate that 30. You don't need to draw a picture if you can visualize it in your mind, but some people need to do that. So that's calculating the angle between two vectors when we're given the when the vectors are given in polar form or with magnitude and direction. Let's have a look at doing it with when the vectors are given in component form. So we'll draw a diagram and draw two vectors in here. So let's say something like that, and we can say this is A, and this can be B, which can be maybe -2, 3, for instance. And say we want to calculate the angle between these two vectors. There's two methods what we can do. We can convert into magnitude and direction. So we can convert this to find our angle here and our angle here, and we can subtract them. So I'll quickly show that. the way this works is we draw each vector separately. We've got 2 across and 3 up, so we can work out this theta. So our theta, let's see what that is. At 56 degrees. So working out this angle here, let's call it theta 1. 180 minus theta. We get 123.69 degrees. Okay, so we've worked out this part. Now we need to work out this part. So doing that, we can go draw a diagram again. We've got 4 across, 2 up. Be theta 2. We get 26.57 degrees. Then our difference here, so this angle here is just going to be theta 1 minus theta 2. So let's call it beta. We'll label that on there. 123. And we get 97.12 degrees. So a little bit cumbersome because we have to draw our diagrams here, get our angle, we need to convert the angle to this one, etc., etc. Does take a little bit of time. So there's an alternative way that we can do this, and it has to do with the dot product, because the dot product is quite easy to calculate when we're given the vectors in component form. So let's write out our definitions for dot product. That's one. That's the other one. So if A dot B equals this and A dot B also equals that, we can equate the right-hand side of both of those equations. So we can say now in this case, we just need to multiply. So we need to work out that dot product, work out what the magnitude of both vectors are, and we can work out, and we can use that to work out the angle or find the unknown. So a little bit different. We don't have to draw these triangles out, but we do have to find the magnitude. So showing the working for this, we've got -2 times 4. A is the square root of 4 squared plus 2 squared, square root of 2 squared plus 3 squared. Okay, so we got -8 plus 6, -2, 16, that's root 20, and I could simplify it, but I don't need to. 4, 9, root 13, cos theta. So theta is going to be so that's my theta, and I can work it out. And I get 97.13 degrees. What do we get down here? Got the same. I probably had a rounding error here because I had 2 of these, which I rounded. So we get the same angle. In this method where we're using the dot product, we only have to find the magnitude. We don't have to mess around with these triangles and the conversions of flipping the angles from this angle here to this angle over here. So different method. This method is often used when you're given vectors in component form because it's a bit more algebraic, a little bit less messing around with your different angles, but either method can be used. Often you'd use this one because it's a little bit more straightforward. Okay, so that's the video on calculating the angle between two vectors. I hope you enjoyed it, and I'll see you for the next one. This video accompanies a worksheet series that aims to develop conceptual understanding with vectors. If you'd like to access the worksheet, click in the description below.